Okay, so today is 6.8, solving formulas. So basically using the same style of rational equations that we've been doing, but then solving for letters instead of just solving for a number. So first question always to ask is why? Why do we actually solve formulas? Why do we bother at all? The situations where solving a formula is going to be a good idea is for anything with a repeated use. So you're going to use the formula more than one time, and the variable that you're trying to solve for, it would have to be solved every single time. So that's really not helpful. Another time that you're going to solve a formula is for substitution method, so that you can substitute one equation into another. And then the third, probably most common usage for solving formulas is for grapher use. Your basic TI grapher, the graphing function is set up where you have to have y solved, or you can't put the equation into the grapher. So in order to use a grapher, you have to be able to solve for y, and then you can put the equation in. So those are the three main uses of them. So let's do an example of just basic usage. So 2x plus 5y equals 4. This is standard form of a line. So let's say that you want to figure out what y is when x has the domain of -3, 2, and 6. If we use the equation as is, you're going to have to completely solve for y 3 separate times, which is a lot of work. So much better is to solve for y first and then sub in. So we would subtract 2x. So 5y equals -2x plus 4. Multiply both sides by a fifth. And you get y equals -2x plus 4 all over a 5. This form will make it a lot easier. In fact, you'll probably even be able to do it in your head. So using that form, if x is -3, -2 times -3 is 6. 6 plus 4 is 10. 10 divided by 5 is 2. Very easy. If x is 2, -2 plus times 2 is -4. -4 plus 4 is 0. And then the last one was a 6. -2 times 6 is -12. -12 plus 4 is -8. So we would get -8/5. So much faster than having to do the algebra 3 separate times. So that's a basic equation. You solved for y lots of times in Algebra 1 because you were typically putting the equation in the form y equals mx plus b, which we commonly call the graphing form. It's actually a slope-intercept form, but it's a very easy form to calculate in. So that would be probably where you saw that most of the time. Okay, so let's go on to our Algebra 2 level of equations. So we're going to do some practice. And one of the formulas that's going to come up a lot is the resistance formula. And I'm not an electrician, but the resistance is, if you didn't have resistance in the plugins on the walls, you would plug in an appliance and it would be like a lightning bolt hit. You'd get the full power of the power lines, which would blow you and your appliance up. So what they have to do is figure out how to step the power down to where it's usable by the appliance and won't melt the appliance or you. So the resistance formula is 1 over capital R equals 1 over lowercase r sub 1 plus 1 over lowercase r sub 2. And in this formula, the capital R is the total resistance in the system. It's what you get. And then R sub 1, R sub 2, R sub 3, R sub 4, R sub 5, those are your resistors. And of course, the higher the power and the more you want to step it down, the more resistors you need. So they're going to give you this resistance formula. And they're going to usually use a semicolon and say, hey, we want you to solve for r sub 2. All right, so let's see. 1 over cap r equals 1 over r sub 1 plus 1 over r sub 2. So there's a couple ways you can do this. Probably the easiest one is to get the 1 over r sub 2 alone. So if we subtract 1 over r sub 1 from both sides, that gives us 1 over r minus 1 over r sub 1 equals 1 over r sub 2. To flip r sub 2 to the top, we need to do flippy step, but that means we need a single fraction on the left. So we're going to put these two together using what you already know. So to get a common denominator, the first one needs an r sub 1. So multiply by r sub 1 over r sub 1. The second one needs a capital R, so multiply by r over r. Now that they have a common denominator, put them together. You get r sub 1 minus r all over cap r sub 1. So all we did there was add fractions, which we've been doing. Okay, now that you have a fraction equaling a fraction, we can do flippy step and flip both sides of the equation. R sub 2 goes to the top, and then on the right I have capital R sub 1 over r sub 1 minus r. And that would be the formula solved for r sub 2. So in that case, we wanted to get the 1 over r sub 2 alone, make it a fraction equaling a fraction, and then do flippy step. All right, so that's one of the formulas you're going to come across on your homework. Okay, example 2. Another formula that they throw at you is the volume of a pyramid. Which is capital V equals 1/3 capital L squared H. Now, what's interesting about these formulas is you don't actually have to understand the formula to solve for it. Solving is algebra, it's not interpretation. So we don't really care what L and V and H are, although V is probably volume, H is probably height, but we want to solve for the H. Okay, so to get the H by itself, I need to get rid of the 1/3 and the L squared. Now, because they're next to each other, you know they're being multiplied. And the way you remove a multiplied scalar is the reciprocal. So I'm going to remove the 1/3 first. I'm going to multiply by its reciprocal, which is 3 over 1. If you do it on the right, you have to do it on the left. That will cause the 3 to cancel. So that gives you 3V equals L squared H. All right, now I need to get the L squared off of the H. So I'm going to multiply by the reciprocal, 1 over L squared on both sides. So now the H is alone, and I have a 3V over an L squared. So if your terms are being multiplied together, to remove terms, you just multiply by the scalar. Sorry, the reciprocal, the reciprocal of the scalar, excuse me. So you just flip it and multiply. All right, example 3. Some of the formulas, you won't have any idea what they are. XR plus 3 equals XY. And we want to solve for X. So what makes this one kind of different is that you have an X attached to an R and you have an X attached to a Y. You can't add those together. One has an R, one has a Y. They are different terms. So how do you do that? Okay, so the way you do that is you move all the X terms to the right. So we're going to subtract XR over to the right. So that gives me 3 equals XY minus XR. Now, to get the X in one location, you're going to divide out an X from both of those. That X goes to the front, and you're left with Y minus R in parentheses. Okay, now I need to remove the Y minus R. X and the Y minus R are being multiplied. That's because you have a monomial against a parentheses. So we're going to use the reciprocal. We're going to multiply by 1 over y minus r on both sides. This will make the y minus r cancel on the left. X will be alone. Tops times tops, bottoms times bottoms. I get 3 over y minus r. So if your variable is in two different locations, isolate all the terms with your variable on the right or left, and then factor out the variable, and then peel off the binomial. All right. Number 21 from the worksheet, they have kind of an interesting setup. You've got a candle, and then you've got a lens, and then you have the image of the candle, which is upside down, which is basically how your eyeball works. When your eyeball sees the candle and it hits your lens flips the image upside down and projects it on the back of your eyeball, which is why it's upside down. So in this setup, the variable P is the distance from the object to the lens. The variable Q is the distance from the lens to the image of the candle, the upside down image, that's Q. And the focal length is from the lens to the point where the image is flipping over. So the relationship between the distance of the object and the lens and the image, and the focal length is 1 over P plus 1 over Q equals 1 over F. And that is a relationship you will need to have for number 21. For 22, this is a baseball one, and if you don't know baseball, this could be a bit strange. The equation they give you is A equals 9R over I. And those of you baseball fans probably already know this, but A is what we call your earned run average, A for average. The capital R is the number of earned runs that you have. And I is the number of innings that were pitched. And if you feel like you need more information than that, I would say Google it. It's a very common calculation for baseball, but I wanted to make sure you knew what A, R, and I stood for. All right, that is the end of the notes. Are there any questions?